Hello, I'm Scott Snelling, the founder and CEO of Roebling Labs. We do bridge monitoring with video sensors. Earlier in my career, I experienced a bridge inspection near miss. My partner and I were inspecting the underside of a bridge using a snooper truck when a pin failed and we free fell 20 feet, splashing down in the waterway below. It was a inlet to the Atlantic Ocean at the border between Rockaway, Queens, New York City, and Long Island. Uh, the steel cage was quickly submerging to the bottom of the channel. Luckily, my partner and I were able to quickly unclip our harnesses before being dragged to the bottom. We were swimming in the cold water. And fortunately, a nearby fishing boat saw our predicament and came to pick us up. We had no serious injuries. But I know firsthand how difficult bridge inspection can be. Uh, and bridge monitoring won't replace bridge inspection anytime soon, but bridge monitoring can make bridge inspection more productive, more thorough, provide quantitative data, and increase the safety of both bridge inspectors and the traveling public, all while decreasing life cycle costs to bridge owners. The problem as we see it, this is specific to the USA, but similar issues can exist all around the globe, is that there's 600,000 highway bridges in the United States. 40,000 of those, or 7%, are in poor condition or structurally deficient. Only about 60 or 0.01% of bridges have structural monitoring systems. Existing bridge monitoring systems are expensive, difficult to install, and provide abstract data that's difficult to interpret. Our vision is to monitor every bridge. Every pixel is a displacement sensor using our system. And quantitatively, our virtual sensors measure structural deflections to an accuracy of about a thousandth of an inch. Qualitatively, our motion amplification software is like a microscope for movement. Imperceptibly small deflections become visible for the first time. Before I show you some of the features of our system, I want to talk about our collaboration with Bentley iTwin Activate program. Reality modeling is a key part of the iTwin platform. So we started our project, our collaboration off with some 3D reality modeling. So it uses drone photography. We ramped up the learning curve and we're able to produce a high quality 3D reality model of our local example bridge, which is shown here. But really the goal of our project with iTwin Activate was to develop a dashboard for bridge monitoring using the iTwin platform. Shown here with, this is a 3D model of that example bridge, just a simple CAD model. And then you can place the virtual sensors there. This app is available, on the internet. And once you place those virtual sensors, you can click on them and it brings up a frame showing the results of our video sensors. Before I show those, I'll talk a little bit about our setup in the field, which you see in the lower corner. That's what we call our inspection camera. It's the inspector can bring it out, use a tripod, set it up, and needs to operate the camera with them. We have another camera model. We have two different models. The other one is our monitoring camera, like this one here. This video camera actually, a Windows computer is built into the back of the camera. This can be put in a weatherproof housing, and it can monitor the bridge for days, weeks, months, years at a time without anybody out in the field. You can remote into that computer using cellular modem and so forth, and get all the data and do all the operations remotely. So to show you the measurements here of the video, let's see. This is a truck going over our example bridge. You can see the readings from those virtual sensors. Those are all being taken from the video camera. There's no sensor on the physically on the bridge itself. You can see, we'll show, here's a close-up of that sensor at midspan. As the bridge comes over, the bridge starts to deflect down about 300 thousandths of an inch, which is, 300 mils is 300 thousandths, which is about a bit more than a quarter of an inch, which is perfectly normal. Likewise, we'll next see the green sensors here at quarter span. The deflection's less, like 90 thousandths of an inch, so less than a tenth of an inch. Again, this is all perfectly normal. So these sorts of normal readings can give an owner the peace of mind that their bridge is operating normally, even under heavy live loads like this truck. It's actually a semi truck with a steamroller on the back, so it's a quite heavy load that came over here. With with that, I'm going to go back to our presentation. Let's see. Yeah, I'd also like to show some videos of just our system in general. Let's see. So this is some footage of a motor. The motor's rotating, but you couldn't see anything. But then when we use our software package to motion amplify that same video, you can see the base plate crack opening and closing. That same sort of technology would work the same on cracks on bridges, where you can see a crack expanding and closing under live load, or some cracks like shrinkage cracks may not have any effect under live load, and they're not something to worry about. So this is a tool that can separate structural cracks from cracks that we aren't worried about. Here's a motion amplification on another bridge. You can see it's the same video, top and bottom. The below one is what you'd see with your naked eye, and the one on top is motion amplified. You see the movement under the truck. Likewise, the next video is of a pedestrian bridge, and here it is. And you can see that torsional movement. It's motion amplified. You wouldn't see that with your naked eye, but the video sensor and software makes it visible. And then likewise, you can see that time series graph of the deflections on either truss opposing and showing that torsional movement. Moving on to the next steps, we'd like to keep improving our bridge monitoring dashboard using the iTwin platform. Some of the features we'd like to, bring in is the reality modeling. We'd really like to be able to place those virtual sensors on our reality model of the bridge. We'd like for, to bring alerts of excessive deflections onto the platform. So right now our system, you can monitor the bridge when a deflection exceeds a threshold, you'll get an alert. But that alert is separate from it's right. We would need to bring that onto the iTwin platform for iTwin users to get their alerts there. Likewise, downloadable time series, the video. Right now, our video that we bring into iTwin shows the time series, but it's also possible to be able to download that time series data. And that's possible elsewhere on our platform, but not currently possible on the iTwin platform. Likewise, the archive and retrieval of videos and data is something we would like to add. It's one thing to show a 10-second video clip, but it's something else to organize, years worth of videos and data in a way that's friendly to the user. Finally, to integrate with iTwin, we'd love to see video integrated into the iTwin viewer. Motion amplification could likewise be integrated into iTwin. Right now, all those sorts of motion amplification software adjustments are done on our platform, but that could be integrated into iTwin so the iTwin user can do those adjustments right on the platform. We'd also love to see procurement, distribution, and billing of bridge monitoring services through iTwin. We think that would greatly ease our distribution channel versus having to establish new distribution channels with bridge owners around the world, since Bentley already has the software platform with those existing software subscription relationships. We think there's an opportunity to bring our service on the platform and share the profits in doing so. With that, I'd love to take some questions.